Hi, today we are covering 4.6 isosceles and equilateral triangles. By the end of today, you guys will be able to use properties and understand isosceles triangles as well as equilateral triangles. Our new vocab is legs of an isosceles triangle, as well as vertex angle and base angles. So we have two new theorems, isosceles triangle theorem and converse of isosceles triangle theorem. The isosceles triangle theorem states, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically, if these two legs of our isosceles triangle are congruent, then the two base angles, angle 1 and angle 2, must be congruent because they are opposite of their respective sides. Similarly, the converse states, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if these base angles are congruent, then the legs of the isosceles triangle must be congruent. So let's do a quick example here. We don't really have an example like this on our notes, so I'm going to write one out here. We have our vertex angle 50. That just means it's not the base angles, the opposite angles from our congruent sides. So if the vertex angle is 50 and we know the opposite angles have to be congruent, or the base angles have to be congruent, then we can say that these are just some variable x. So we can say x plus 50 has to equal 180 degrees. Or you might be able to think through it in your head that, well, the whole triangle has to equal 180, so the remaining two pieces have to be 50 less than that. And then because there are two of them, we divide by 2. Either way you think through it, you end up getting the same solution. So you solve it out, you end up getting that each of these base angles both must be 65 degrees. Okay? This one's also 65. All right, so that's just a quick little example of how you can use that. Now we are going to prove our isosceles triangle theorem. So this proof has two steps that are a little different than we normally do, but otherwise we can finish it out from there. So we are given that the isosceles, we have an isosceles triangle, ABC, and it has sides AB congruent to segment AC. That's given. It's already drawn for us as well. So this next step is one that we don't usually take, although it's completely valid, that we let there be a midpoint, and we're going to call it D. Seems kind of weird, but believe it or not, since every segment can have a midpoint, we could state that any segment does. So we know every segment has a midpoint. Most proofs, this isn't really helpful to us, so we obviously don't do this step, but it is possible. So we're going to let D be the midpoint of segment BC.
Will Dave or Mandy Bailey please report to your classroom? Dave Bailey or Mandy Bailey, please report to your classroom.
Sorry about that. Then step 3. Because we now have a midpoint, we can draw in a segment, a new segment. So you can say make a new segment. The fancy math terms are draw an auxiliary segment, but just saying make a new segment, AD, is fine. And that is because at the way beginning of the year, probably day 3, we know that 2 points make a line. From there, we have enough to finish proving like we have the past couple of days. We can state by the reflexive property that AD is congruent to AD. It would be a good time to point out what we're actually trying to prove, since I didn't state that earlier. Hopefully you saw that angle B is congruent to angle C is what we're trying to prove. So, we can finish out this proof by proving the triangle is congruent and then getting that corresponding part is congruent. Now, since we stated something with midpoint, we're probably going to want to use it. So I'm going to say that BD is congruent to DC because of the definition of midpoint. That means these two segments are congruent because D cuts it in half. Now I have enough to go ahead and say that my triangles are congruent. Make sure to be picky about the order you put them in, especially for the second one. So ABD would be congruent to triangle ACD. And that would be by side, side, side. And then my last step here, I can go ahead and state my proof statement. Angle B is congruent to angle C because of corresponding parts of congruent triangles are congruent, or CPCTC. Now this proof you won't have to rewrite on your homework or anything. It's just to prove that we can now do algebra with the isosceles triangle theorem forever, okay? So, we're not going to actually do algebra right this second, but instead we are going to use the isosceles triangle theorem to determine two unmarked congruent angles. So we want specifically unmarked congruent angles, which means I should probably look at my sides. I know my opposite angles must then be congruent based on those sides. So I can say that angle A is congruent to angle BCA. Make sure not to just say angle C, because angle C actually refers to three different angles. Who knows which one you're actually talking about? So you gotta be particular. Angle A is fine because it really only references this one. So I just said that these two angles are congruent. It's because of the isosceles triangle theorem and our opposites. Now we need to name two unmarked congruent segments. So now I need to look at my angles on my other piece, and I know my opposite segments must be congruent. So segment DB must be congruent to segment BC. All right, now we get a new picture. It asks which statement correctly names two congruent angles. I would suggest highlighting the angles it's talking about. So the first one is PJM, and then it's PMJ. So we're talking about this angle and this angle. Well, we can't definitely state those are congruent because we don't have their opposite legs of the isosceles triangle congruent. So we can't state that. The next one, we have JMK and JKM. Now this one looks promising. We have these opposite sides, or the legs of our isosceles triangle, congruent, which means these opposite angles, which are what is highlighted in blue, need to be congruent. So I will say B is the solution if you want to take a second to trace out the rest to see why they are false. K, J, P, and J, K, oops, sorry. JKP cannot be congruent for the same reason as A, because we don't know those two pieces there are congruent. And lastly, I had a lot of students choose this one in class. PML, it would be nice if we had this one, but notice we actually have PLK. This angle is definitely not congruent to that angle, so D is not a choice either. All right. For this next one, we are going to which statement correctly names two congruent segments. I'm actually going to do it a different way this time. I know it's not going to be my two named ones, so might as well not even look at that, but instead look at these base angles. I know the opposite sides must be the ones congruent. So I'm going to search in my list and hope that PM and PK are there. And it turns out that they are. So D is our solution. You can kind of just check through the other three and notice that they are not congruent. Okay, now we have equilateral triangle corollaries. They just kind of come from our theorems and postulates, but they still are true and hold true. So we know a triangle is equilateral if and only if it is equiangular. So if you are given a triangle and it only shows you that the sides are congruent, you also know that the angles are congruent. And vice versa. If it only tells you that the angles are congruent, you know that all the sides must also be congruent. And then following that, each angle of an equilateral triangle must equal 60 degrees. Because all the angles are the same, you can take 180 divided by 3, since there's 3 angles, and they all must have to be 60 degrees. So from here, we are going to find the missing measures. Do not assume when you're only given one or even two sides, one angle or two sides, that you definitely know that it's equilateral. We can use our opposite angles ideas though, because we can at least know that these are isosceles, right? So if this is an opposite angle and this is an opposite base angle, we know that these two must be congruent. We know that a triangle is 180 and we have 60 less than that left for our remaining two angles. So these guys must also be 60 degrees. So it is definitely an equilateral triangle. So we can go ahead and say that the measure of angle R is 60 degrees. And if it's an equilateral triangle, we can go ahead and state that the length of PR we know is 5 centimeters. Once again, don't just assume these things. Make sure they're actually true. Don't just assume that it's an equilateral. Because this angle could be like a 30 and 90, or, you know, something other than that. They still equal 180, though. So we have to find out. So we know this guy is 3.5 and 60 are opposite of each other. We know this 3.5 also has an opposite angle, which must be the same. So it is 60. That leaves angle R also being 60, so the measure of angle T is 60 degrees. And if it's an equiangular triangle, it must mean that it's equilateral, so TS must equal 3.5 units. All right, we have 2 more slides. We are going to find the value of each variable. So Y is pretty easy to solve for, because they are both congruent sides. We have that going for us. We can go ahead and solve for Y. So Y is going to equal 4. If you plug it back in, these would be congruent to each other. The angles to solve for X are a little trickier though, although we can figure it out. We know that these guys are congruent, which means that this opposite angle is 4x minus 8, meaning angle D must be congruent to 4x minus 8, or just the same thing. Now don't fall into the trap of setting these equal to each other. Like this. If they were 2 different expressions, you could, but they're not. So you know, since this is an equilateral triangle now, since all 3 of these are the same, it must be equilateral. Oops. Since you know it's equilateral, each of these individual angles has to equal 60. So you can set one of these equal to 60 degrees. Or If you preferred, you could add all 3 angles up. And equal them to 180. You'll get the same solution for x. I think it's easier to do the top way, so I'm going to solve like that. So we get x equals 17. If you plugged it back in, that would get you 60 degrees for all 3 of those. Make sure when you are solving these on your homework, if you're only given 2 angles like they did here, don't just say that 4x minus 8 plus 4x minus 8 equals 180. It's all 3 angles have to equal 180. So you either need to figure out what you can say the 4th angle is or solve it some other way. Don't say 2 angles added equal 180. That is false. Unless you're talking like supplements or something. If you're talking triangles, can't do that. All right, last problem. We know this is equilateral because all the sides are marked that. So go ahead and set these equal to each other to solve for y. So y must equal 7. Then we know, once again, that this is also 3x, so you can set this up a couple different ways. You can say 3x equals 60. Or all 3 angles, so 3x plus 3x plus 3x equals 180. Once again, you'll get the same thing, but for some of you, it might make more sense to do it one way versus the other. And we are done. Alrighty, have a great evening.